Okay, so day 3 of curve sketching here. Uh, and I think I'll probably do about 2 or 3 examples of curve sketching. And if I'm going to do those curve sketching examples, it'll take a little while. So it might be 2 days. If I have to break this in 2 days, we'll see. So I'm calling this part 1. So basically all we're doing is we're going to use both derivative tests to help sketch a curve without using any technology, just doing it by hand. So the first one I'm going to do is actually kind of a complex one. It's an even function, so you know that it's going to open like upwards like this, so it might go like this or whatever from your pre-cal 30 stuff. So in these, this is what your assignment will look like. You're handed. You'll have to find critical points. You'll have to state the max and min values. You have to find the inflection points, areas of increase and decrease, and areas of concavity, and then you sketch it. So let's do an example of that right from the get-go, step by step. So I'll take my marker out here. I'll see if we get 2 done today, maybe only 1. Might do 1 today, 1 tomorrow. We'll see how it goes, or maybe depending how fast we are. So let me get my timer out actually, so I can keep track. I don't want to go too much past that 30 to 35 minutes. Okay, so there we are. And let's get our marker set. Okay, so the critical points are derivatives set to 0. So let's do the critical points right here. Okay, so we've got to go y prime is equal to 4x cubed minus 108, 54 times 2, x. Okay, so that means we can take out a 4, I believe, into here. Four x comes out times x squared minus, I believe this is 27, times 4, that's 80, and 28. Yeah. Okay, so then we can factor this because this is a difference of squares. You're like, no, it's not. It's not a perfect square. I know it's not, but it's still a difference of squares. Anything can be rooted. This is root 27. So this can be factored. This is why I wanted to use this one to show you. Anything that's got a positive x squared and a negative number is a difference of squares. It doesn't have to be, it's not grade 10 anymore. It doesn't have to be a perfect square because the square root of 27 is a number. Okay, so this would be x plus the root of 27 times x minus the root of 27. Okay, so that gives us our critical points. Now, what is the root of 27? Let's do a decimal point. You can leave it as a root of 27 if you want. So 4x equals 0, or x plus root 27 equals 0, or x minus root 27 equals 0. So that means x equals 0 is one critical point, x equal negative root 27 is another, and x equal positive root 27. Okay, so that gives us our 3 critical point x values. Now let's see what root 27 is here. 27, root 27, not 27 cube root. Okay, so if we do that, we get 3 root 3, which is 5.196. Let's go 5.2. If you'd rather use decimals, I'm okay with that as long as you approximate well, because you're just doing a curve sketch, not a graph. So there is our values. Now, if we plug them into here, we're going to get our points. So one critical point is at 0, 0. Because if you put 0 into there and 0 into there, you get 0 for y. Now we're going to plug it into here. y equals 5.2 negative to the fourth power minus 54 times negative 5.2 squared. What do we get? Let's use our calculator for that. Okay, so so 5.2 to the power of 4. Oops, I put squared in there, sorry. Okay, and then we get minus 54 times 5.2 squared. So I get like 729 negative, approximately. So our critical point number 2 is negative 5.2 and 729 negative. Okay, and our critical point number 3 is 5.2 and what do we get there for that one? Probably a similar number with a positive sign because it'd give us the same value, but this would be a positive, so you'd be minusing it, and this would be positive, so negative 729 as well, right? Because if that's a positive or a negative, it doesn't really matter. So you get the same. So there, it's kind of a symmetrical graph. So then we have a min value here, a min value here, and looks like could be a max value there. But we could test it out with our min max type stuff. So let's go ahead and do the inflection points next. Okay, we've got a min, and this could be a max. It might not be a max, it might be an inflection point. But now we'll just label it as max, and then when we do the inflection points, we'll check to see if it's an inflection point. Okay, so areas of increase and decrease, and inflection points. So let's do the inflection point part here. That was A, this is kind of B here. And C is the inflection point. So we've got our derivative here. Y prime equals 4x cubed minus 108x. So we'll do y prime prime. 12x squared minus 108. So let's not forget the squared. 12x squared minus 108. Okay, when we do that, we can divide 12 into 108. When we do that, we get 9, I guess. So this would be 12 times x squared minus 9. Divide out the 12, and then factor the x plus 3x minus 3. So that looks like that is a max value. That's not an inflection point because there's no x out front, or let's see, there's no x out front. It went in here. So we've got x equals negative 3 and x equals positive 3 as inflection points. Now, if we want to plug them into the original equations and get what they are, let's do that. Y equals 3 to the fourth minus 54, 3 squared. So let's do that. 3 to the fourth is 3 times 3 times 3 times 3, which should be 81. minus 9 times 50, 54 times 9 minus 486. 405 negative. And the negative 3, if we squared that and we cubed it, it's going to give us the same thing. So we're going to have IPs at 3,405 negative and negative 3,405 negative. Okay, so we've got our inflection points. We've got our critical points. We've figured that out. Our intervals of increase, decrease, and our concavity is next. All right, so let's do our interval of increase, decrease. Okay, so we'll do a sign analysis of the first derivative. Okay, let's make sure that we do it in the right row here, D. Okay, so to put our line and our first derivative, if we look back at our first derivative up here, we had 0, negative 5.5, and positive 5.5. Or 5.2. Can't read my own writing. Okay, now my factors were 4x, x plus 5.2, and x minus 5.2. Okay, so then the 0 one is going to be there, and we're going to have negatives and then positives here as we go past the 0. Okay, now x plus this, so that it would be 0 at negative 5.2, and that would be negative below that and positive above it. And finally, this one here would be 0 at positive 5.2. We have positive 5.2 there. So then it would be negative below it, like everything below that, and everything above it would be positive. And then if we multiply these together, this one times this one times this one, that's 3 negatives. Negative, positive, negative, that's positive. Positive, positive, negative, that's negative. 3 positives. So our area of increase, okay, it's from negative 5.2 to 0, and from 5.2 positive to infinity. That's this area and this area. And we're decrease. Okay, we're looking at infinity, negative infinity to up to negative 5.2. And our positive area, or sorry, our negative area, also 0 to 5.2. Okay, now area of concavity. This is where we go into the second derivative test. Okay, so the area of concavity, the y prime prime, was equal to 12. What was it? 12x squared minus 108 x, or was it just 108? Yeah, 108. So that gave us our factors of 12, so we had x plus 3, x minus 3. That was what we had. Okay, so then if we do our second derivative test now, a sign analysis with that. We had up. Okay, so we've got a -3 and a +3. So we've got 12. 12 is never negative. It's always positive. X plus 3, X minus 3. So X plus 3 is a 0 right there. Negative there, positive up here. X minus 3 is a 0 right there. Positive above 3, negative below 3. For example, you put 2 in there, you get a negative number, right? And this would be a positive, this would be a negative, and this would be a positive. So concave up from negative infinity to -3, and from +3 to positive infinity. That's our concave up. In this case, did I do this one right here? Negative, just double checking here. From -3 to -4, yeah, that's negatives. And yeah, I did. All right, and this would be concave down would be in the middle here, from -3 to +3. Okay, now sketching it, we have to kind of take all things into consideration, our critical points. Okay, so let's we'll flip back and forth for the sketch. Okay, so let's go ahead and put our critical points. 0, 0. Where is it? 0, 0, -5.2, and -729, -729. So we got a maximum at 0, 0. So let's do that sketch first. Okay, so we put a 0, 0 there, and a minimum down here, and a minimum down here. Okay, and then we have an inflection point. This is -5.2 and -729. This is -5.2 and -729. And this is 0, 0. And then it kind of goes like this through here, like that. And then it's going to go sliding upwards as you go past your. Okay, so it's going to. So now we have an inflection point here at -3. Okay, and what do we have? It was -405. So -3 and -405. And then we had another inflection point here at +3 and 405. And then it's just going to kind of curve up like that. We could plug in some numbers and figure out what they were. But we know it's going to go like that. And that's kind of our curve sketch. Okay. That takes us to about 20 minutes. We'll do one more example. I'm going to pause this and find a second example to do. And I'm also going to put this up on Desmos to show you what it would look like, just to double check our work. Okay, so I put it into Desmos. Now, I wouldn't recommend stick it into Desmos to double check things. Now, you notice I didn't actually went and found where the x-intercept was, but if we look at our maximum, there it is. If we look at our minimum, it should be at that 729 range. There it is, negative and 5.196 or 5.2 like we did. Here's another one there that we had. And then we could have went and tried to figure out these by putting in 0 for y and solving. or just kind of putting some points after negative 5.2 in to figure them out. But we just know that it curves up like that. So there's our curve sketch. Okay, so let's do another one. Let's get this out of the way here. Available to us. Let's get my board back up here. So our sketch is there. Make sure you're labeling your IPs. I should put them, whether it's an IP or max min. So these are IPs. Okay, we didn't find the IP on the Desmos example because it doesn't show that, it just graphs it. But if we were looking at it, you could see that it's concave up here, and then it shifts to down somewhere halfway in between, and then back up again. So you can visually see that. So that, I think, what was it, 3.405, negative 405, somewhere in here. So somewhere in there is our inflection point right there, right at that point right there. Okay, so let's do another example on a new page here. Let's see if I want to get I don't want to do a fourth power one. Let's do a third power one. Okay, so I've got one in front of me here. It's got fractions and stuff again, whatever. Doesn't matter. Okay, so example 2. So what I'll do is I'll do another example. And then tomorrow I'll give you a day to do some practice as well. Let me just, I think I can maybe find a better one. Let me take a quick look here. What I had on the, yeah, this one looks good. Let's do a fifth power one. That'll be fun. Okay, so let's say I had a y equals 3x to the fifth minus 10x cubed. So if you have to break this up there into our y prime, 15x to the fourth minus 30x squared. So if I take this, set it to 0, we get 15x squared out here times x squared minus 2. Okay, remember that is a difference of squares. So we can factor that into 15x squared. And this one would be x minus root 2, x plus root 2 for our critical points. Root 2 is 1.41. So we can use that as our root example here. If we don't want to, if we want to use decimals like we did last time. Okay, so let's go ahead and say that 15x squared equals 0, x minus root 2 equals 0, and x plus root 2 equals 0. So x can equal 1, or 0, not 1. X can equal positive 1.4, and x can equal negative 1.4. We'll just use one decimal for our curve sketch. Okay, so if we do this, plug in our numbers, we have a critical point. Remember, we're doing the same 5 things that we did before. At 0, 0, we have a critical point at 1.4, and if we plug it in, 3 times 1.4 to the fifth minus 10 times 1.4 to the third. So 1.4 4 to the 5th times 3 minus 10 times 1.4 to the 3rd. Oops, did that wrong. Let me do that again. 1.4 to the 3rd times 3. Put a negative in front of that. And then we'll add 3 times 1.4 to the 5th. And we get, what do I get there? About negative 11.3. Okay, and then this one here, we get negative 1.4, which is going to probably change the sign, but let's double check it just in case. So okay, so we got that. Power of 5. Okay, let's see. Let's see, I got that one at okay, that's what I kept making the same mistake here. Here. Sorry about that, guys. Just, yeah, so it's the same idea. It's just 11.3. Had trouble with my calculator pushing there. Sorry about that. Okay, so we finally got our critical point, number 1, 2, and 3. Okay, once we've got our critical points, we can get into finding our max and mins. So it looks like we've got a max here. We've got a min here. Okay, and this could be a local min maybe. We'll see when we draw the graph and we can put it up. Okay, once we've got our max and mins, we now want to find the second derivative to find the inflection point. Second derivative of this. So 4 times 15, that's 60. X cubed minus 60x. Set this to 0 to get our inflection points. We get 60 xx squared minus 1. So this is going to give us okay, so we look like we've got 3 possible inflection points here. So this is not going to be a max or min. This is going to be an inflection point, that critical point there. So we can say that 60x equals 0, x plus 1 equals 0, x minus 1 equals 0. So we've got x equals 0, x equals 1, x equals negative 1, x equals 1. So we've got 0, 0. Okay, now if we put the 1 back into there, 1 times 3 minus 10 is negative 7. If we put the negative, or sorry, that's negative 1. Let me do this correctly here. So that one goes under the other one. 1 and negative 7. And then we have negative 1. If we put negative 1 in there, we get negative 3 plus 10, which would be 7. So these are IPs. Okay, now we're going to check for areas of increase and decrease, and then areas of concavity, and then we're going to sketch it. Okay, so let's go ahead and do the first derivative test. We'll do it underneath here first. Okay, so increase, decrease. So we've got to have our first derivative. Our first derivative was with the root 2's and stuff. So we had a negative 1.4, a 0, and a positive 1.4. And then what we're analyzing was 15x squared. One factor, the other factor was x minus 1.4, or root 2, x plus 1.4. So this is 0 right there, but it's positive all the way through. Okay, this negative 1.4 is 0 right here, positive up here, negative down here. This one is 0 right here, negative below it, positive above it. So here's our areas of increase, decrease. We have a positive, a negative, positive, negative, negative is positive, positive, negative, positive is a negative, positive, negative, positive again, it's still a negative, and up here is positive. So increase from negative infinity to positive, or sorry, negative 1.4. Okay, and also here, 1.4 to infinity. Okay, so, and we've got decrease. Okay, if we do the decrease here, we've got a decrease in negative 1.4 to positive 1.4. Okay, now we're going to do the concavity test. So that's the second derivative. Okay, the second derivative was, put it up here, y prime prime was 60 x plus 1, x minus 1. So we had 60x, x plus 1, x minus 1, and we had a 0 and a minus 1 and a plus 1. And this 0 and this is negative till 0 and positive after 0. This is plus 1 is 0 right here, so it's negative below that and positive above that. And this one would be 0 right here, so it's positive above this, negative below that. So we got a negative, positive, negative, positive. So concave up is from negative 1 to 0 and 1 to infinity. And the last one, concave down. Okay, that was negative infinity to 1, negative 1, and 0 to 1. Okay, our final step is to try and sketch this now using our critical points. Let's do it in this spot here. So we know that this is going to be, it's a cubic equation, so it's going to go like that, possibly, unless there might not be two curves in it, but we'll see. So the first one we're going to do is we've got a critical point here, here, and here. So we've got a min at negative 1.4 and negative 11.3. So negative 1.4 and 11.3. That's a max. What am I doing? That's a positive. There we go. That's a min. We'll put the negative over here. So negative would be down here. So our negative is negative 1.4 times 11.3. Oh, I got it backwards here. Let me do this the other way here.
Yeah, he is.
So,
They want to come see you.
okay, let me just put this on pause here. Okay, sorry about that. Okay, so I had this backwards. Let's get this a little bit in the better space here. Okay, so let's get our critical points down. Okay, this one was positive. So let's actually put a little axis so that I don't get as messed up. Okay, so a negative 1.4, that's down this way and then up. So right there is negative 1.4 and 11.3. Okay. And then a positive 1.4 and a negative 11.3 down here. So we'll put it here. 1.4 and negative 11.3. Okay. And then we have 0, 0 is a critical point right here. And that's more than likely going to be an inflection point where it changes concavity. And then down, and we have some concavity changes at negative 1 and negative 7 right here. And positive 1 and negative 1.7 here. And negative 7, not 1.7. So this is an IP. So that means it's going to change. It's going to go from concave down to concave up, concave down to concave up. And then here, you're going to have it changing as well. So this is an IP as well. So it kind of goes like this. Then it changes. We have a little bit of like a flattening out there at 0, 0 so that it can change its concavity. Okay, so it kind of flattens out a little bit like that. Okay, and that's our curve there. There's our IPs. There's another IP there. So it goes whoosh. Okay, concave down, 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 switch to up. Flatten out here, switch to down, switch to up. Good. Okay, and that's how it works. Okay, big long video today because we did 2 curve sketches in here. But basically what I'm going to do is get you to do some practice with it. And then I'll do a quick review, one more curve sketch review, and then give you the hand for this unit. And that's how we'll do it. So no practice work. Sorry about the length of the video today, but that's how she goes. Oh, if you want to check it on Desmos, you can check it on Desmos as well. Let's do that before I hit the video here. Okay, so let's change it to our curve. Y equals, what was it, 3x to the 5th minus 10x cubed. Nope, not capital X. Okay, so there you see mine was more pronounced because of I can shrink this axis down a little bit so we can see it better. We don't need as much Y here as we did the last one. So let's go say Let's go from a negative 15 to a positive 15. There we go. So there's kind of how it looks. And I had more smoother curve here, but it's a lot sharper. And then there's that flattening out part. There's our min, negative 11.3, positive 11.3 for our max. And then, okay, if we figure these out at 1.8, then 1.8. Okay, so that's curve sketching. So next day, I'll give you some practice work, and then I'll do one more curve sketch, and then I'll give you the hand-in. And that's kind of how we'll do it. Okay, so best of luck. Close that off, and we'll stop the time. 40 minutes is long enough.